Hey, morning guys, coming at you with some matrix stuff today. First thing on matrices is we have to do the dimensions of a matrix. So we've got one up here already. You've got to decide the dimensions of this. So you're looking at the rows, you're looking at the columns, and you've got to make a choice which way it runs. Is this going to be a 3 by 2? Or is this going to be a 2 by 3? Is it the columns first or is it the rows first? So do you know? Well, it's always rows first by columns. It's always rows by columns. And I tell you the way I remember this is back in the day they used to make a drink called RC Cola. And they still have RC Cola. It's still here. RC, rows by columns. So always remember it's the rows first. So here's your row, here's your row. So there's 2 rows and there's 1, 2, 3 columns. So on this one, it's a 2 by 3. 2 rows by 3 columns. So when you're asked to find the dimensions of a matrix, rows first, columns second. Rows by columns. Let's do another one real quick. All right, how about this? That. So we had 2, 4, 6, 8, 10, 12, 14, 16. So if you walked up to this matrix and you were asked to say, what's the dimensions of this? Is it a 2 by 4 or is it a 4 by 2? Well, rows are first. So 1, 2, 3, 4 rows by 2 columns. So dimensions of this would be a 4 by 2. Now you can really see if you're going to understand dimensions or not understand dimensions if you could do this one. Let's see here. What if we have just this right here? 9, 7, 5. If we just have this matrix, what's the dimensions of this? Rows by columns. So you've got 1 row, you've got 1, 2, 3, 1, 2, 3 columns, 1 row by 3 columns. So dimensions of a matrix, first thing you got to do today, not that bad. Remember a little RC Cola. Here we go. Okay, next up, you got to be able to add and you got to be able to subtract matrices, adding and subtracting matrices. So here's the rule. They have to be the same size. They have to be the same dimensions. So to add and subtract, you have to have them same dimensions. If you don't have the same dimensions, you just can't do it. Let's say we have something like 1, 2, 3, 4. -6, -8, 10, and 12. So you check your dimensions. This one, 2 by 2. That one, 2 by 2. And as long as they are the same dimensions, you can proceed. You can add these together. So here's how it works. You just take the same position. Top row, top left, right here, this is the 1 in the first row, first column. -6 runs with him, so 1 plus -6, that's -5. 2 plus -8, that is going to be -6. All right, let's see here. Where are we at here? 3 plus 10, that's going to be 13. 4 plus 12, that's going to be 16. All right. As long as they're the same size, you can add and subtract them. Let's do another one of those. 7. What do we got here? 15, 20? Let's do a subtraction one this time. So subtraction one. Let's say we have 15, 20, -25. And this is a 9, a -8, and a 7. And incidentally, you're trying to think, okay, is this a 3 by 1 or is this a 1 by 3? So 1, 2, 3 columns, or excuse me, 3 rows, 1 column. 3 by 1, 3 by 1. All right, it's subtraction this time. So just be careful. 15 minus 9. So 15 minus 9, oh, that's a 6. 20 minus -8, that's 28. -25 minus 7. So -25 minus 7, what is that? -32. So 15 minus 9, that's where the 6 comes from. 20 minus -8, 28. -25 minus 7, -32. So just be careful on adding and subtracting. Okay. Oh, this will be your favorite example of the whole day. So for this whole video, this one right here will probably be your favorite. Let's say we had this and that. We have 4, 5, 6, 7, 13, and 14. So in order to add and subtract, they have to be the same size, have to be the same dimensions. This is a 2 by 2. This one is a 2 rows, but only 1 column. So if this one's a 2 by 2 and this is a 2 by 1, they are not the same size. You cannot proceed. So you cannot add or subtract these. So it's just not happening on that one. So you wouldn't even have to work it. That's probably why it's going to be your favorite. Okay, let's throw the next thing on these matrices is when they throw in a scalar. And this is kind of the start of putting stuff together. So they call it a scalar. What number is this going to be here? Number 9. So let's throw a 5 on the outside right here. Just for fun, we'll make it a negative 5. 9, 8, negative 7, negative 6. So when you've got the 5 on the outside, it's called scalar multiplication. And when it's sitting right there, he's going to multiply, 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 multiply times everything on the inside. So your answer for this is still a 2 by 2 matrix, but negative 5 times 9, negative 45. Negative 5 times 8, negative 40. Negative times negative, positive 35. And then a negative 5 times a negative 6 is a positive 30. So when you hit it by the scalar, that's what it's going to look like. So we get problems built out of this, where you got to multiply first and then add or subtract some matrices next. Let's see here. So number 10. Going to have a 6 on the outside and a 4 on the outside. Let's put these numbers in here. So 1, 2, 3, 4, negative 5, negative 6, 13, 9, 5, negative 11, negative 7, and a 3. Okay, so just like any math problems, when you follow a little order of operations, you got to decide, do I add first? Do I multiply first? Multiply. So the 6 is going to hit everything on the inside, and then the 4 hits everything on the inside. You do that first. So we haven't added anything yet. We've got to hit it by the scalar. So what do we got here? I got a 6. 6 times 2 is 12. 18. 6 times 4 is 24. Negative 30. Negative 36. So you hit it by the scalar first before you do anything else. So over here we got to do the 4. So what do we got? 4 times 13, 52. Negative 44. 4 times 9, 36. Negative 28. 4 times 5 is 20. 4 times 3 is 12. And then we get our final answer when we add them together right there at the end. So you've got the 6 plus the 52. Let's go ahead and do some of that. So you got the 6 and the 52, the 12 and the negative 44, the 18 and the 36. So just make sure you're getting the same numbers in the same spots. So what do we got here? 58, 54, what is that, negative 10? Negative 32, negative 4. What's that last one? What is that going to be? Negative 24? Yep. All right, so you're going to have problems like this that you're going to have to do. Multiply first, and then when you're done with the scalars, you add them up for your final answer at the end. Well, adding, subtracting along with multiplying. So how that's going to look for us in a math problem is you're going to have a couple matrices given to you. So here's a couple matrices given to you. Negative 4, 3, 2, 1. 0, negative 2, 6, 8. So here's a matrix A and a matrix B given to you to run with. And you'll be asked to do something like, how about 2A plus, let's go matrix B. So you're going to have a scalar, you're going to take the A times 2, and whatever you get, you got to put it with the B. So for us, it's going to look something like this. So you're going to have to drop in your matrix A, you're going to have to drop in your matrix B. So negative 4, 3, 2, 1, 0, negative 2, 6, 8. So multiply it by 2 first, and then you add it to the second matrix. So let's multiply it first, and then we can add it. 0, 2, 6, 8. So with the 2 on the outside, that just means multiply by 2, everything on the inside. So negative 8, 6, 4, and 2. And then we're just going to add them. I think I can fit it over here. Yeah, you guys still see that. So we'll just look at it right here. You've got the negative 8 plus the 0, negative 8. You have the 6 plus the negative 2, that's just going to be 4. And what do we got here? That's going to be 10 and that. Oh, they're both 10. 10 and 10. So this is more of what your assignment's going to look like. You got a little bit of scalar multiplying, a little bit of adding. Let's try one more of these just to make sure. Let's just do one more. So we'll call this one number 12. And 3b minus a. So let's flip it around. Let's go b first, subtract the a. So scalar 3, multiply it by 3, subtract the a. All right, so here's our job. We're going to take it times 3 first, and then we'll work in subtracting that one. So let's do the times 3 before we do the subtraction. So times 3. 3 times 0, that's still 0. That's going to be negative 6. 3 times 6 is 18. That's going to be 24. So multiply it by 3. Got those answers. Now we just got a subtraction problem. So just go spot to spot. You should have 4 subtraction problems. 0 minus negative 4. Negative 6 minus 3. 18 minus 2. 24 minus 1. So what do we got here? 4, negative 9. So yep, that's right. Yep. 18 minus 2 and 24 minus 1. Let's go to 16 and 23. So this for sure get a handle on, because you're definitely going to see that again. All right, little matrix stuff today. There you go.